Good afternoon, everyone. Welcome to the SkillsFuture Festival at Smart Nation 2022 webinar series, organized by SkillsFuture, Singapore and Smart Nation Office. Today's webinar, entitled Reducing Monotony at Work Using Robotic Process Automation (RPA), is organized in partnership with NTUC LearningHub. I'm Phoebe, and I'll be your host for this session. Today, we will learn more about what Robotic Process Automation (RPA) is and what is its case for robots versus humans, followed by a Q&A to wrap up the session. During the webinar, please feel free to type in your questions using the Q&A function at the bottom of the screen. The speaker will address them accordingly. Without further ado, let's welcome Isa Nasser, Head of ICT Product Division of NTUC LearningHub. Isa, please.
Thanks, Phoebe. Let me share my screen. Okay. Hey, hi, good afternoon, everyone. So thanks for joining this webinar. So a little bit about myself so that you get to know me a little bit. So my name is Isa, and I used to be someone who's an academic. So I used to teach in institutions such as Ngee Ann Polytechnic and SIT in technology. So now I'm in NTUC LearningHub, and NTUC LearningHub, we're an organization and we're a social enterprise. And what we do is we make sure that high quality adult education is accessible to both the people in Singapore and companies in Singapore. And today's talk is about a topic that I think resonates with all of us. I think one of the kind of topic that people always like to listen to is on automation and how robots can take over jobs, right, and tasks. And part of that concern is because now the ability for computers and robots to be able to automate tasks is getting stronger and stronger. But for us to be able to allay those fears, one of the best approach is to really understand those technology. And very few automation technologies is as exciting as the one that I'll be covering today. So it's called RPA, or Robotic Process Automation. So we'll, in this 2-hour talk, so it's pretty long, I'll probably cover an hour, 45 minutes, and then we'll do Q&A at the end. So if you have any questions at all, please write it in the Q&A section. I'll cover about what RPA is, what is all the hype is about, and also I'll cover about the future of RPA. And I think that's even more important. Okay, so without further ado, let's get started. Okay, let's start off with this video about the story of work.
This is the story of work. It started a long time ago, on a Monday, which was handy. For as long as history itself, the humans needed to work. They wanted to work, to grow things and create things and build things, to see what they were capable of, to stand at day's end and say, I did that, which felt pretty good. So they worked more, built more, and created more, and traveled to far-off places. And then someone suggested submitting expense reports for those far-off places. His name was Glenn, and he was a jackass. Anyway, the people kept getting better at work. They built better tools to work more efficiently. They built amazing machines to work faster. They built computers to work smarter. But still, they couldn't do enough work. Because during all that work to do more work, they had created work. And not the good kind. Not the let's sit around and come up with ideas kind. Not the I can't wait to get to work so I can jump into a new project kind. The crap kind. The drudge and data and admin and the damned expense reports. So the humans had to work more at work they didn't like. That made them robotic. That didn't inspire. They had to postpone vacations. They had to miss family dinners. They were pissed. And then something happened. Someone had a really amazing idea. They came into work and said, stop working and start working. The humans thought she might have had wine at lunch, so she showed them a way to put the fun back into work, to waste less time doing the things they hated, to make more efficient the big tasks, to stop making the humans act like robots and start teaching the robots to learn the humans. Not to replace people, but to free them. Even Glenn. Robots that learn you. Imagine the potential, like starting over, to help us remember again that work only really works when we're happy at it.
I do not know about all of you, but doesn't that message really resonate with you, right? I think in today's world, I think as we modernize, we become more of an information kind of economy. A lot of work that we do is pretty repetitive and the kind of work that we do not want to do. So I think within an organization, we want to create value for the organization. But for a lot of the work that we do to create that value, it's of the kind that is repetitive and mundane, and we don't like to do that. So maybe watch, and basically what that is an advertisement, right? Isn't it? For RPA. It resonates with us because we feel it, right? Maybe this technology could be something that could solve our problem about being motivated about work and being excited to go to work, because we get to do only the meaningful things and not the repetitive stuff. And that is exactly why this technology became very, very big. So if you do not know, right, RPA as a technology, and I'll tell you what it is later, but as a technology itself, it has seen an exponential growth. So what it means is that in 2017, okay, the kind of revenue or the market size of RPA was this much, about 330 million, 350 million. And you can see that it has grown, quite a lot to a multi-billion-dollar kind of market. So even today, it is one of the technologies that is increasing in market size in the highest speed in terms of the software technologies. So it is really something that is really big. And when something that is increasing or growing exponentially, typically it hits us pretty hard. And I think for a lot of us that are here, you might have encountered your companies exploring RPA or other companies exploring RPA. Okay. So at the fundamental level, as people, as who we are, we always knew that robots and computers are good at doing something. And whereas humans, we are good at doing other things, right? There's a delineation of tasks where we do not want to do and we rather robots do, right? I mean, to put it like in a very obvious manner, let's say we used to have a rickshaw, right, where we pull human beings. So that kind of task we do not want to do because it's very tiring, right? It's very physical. So we rather have a vehicle to do that. So we know that certain things we want machines to do. So in fact, things that are repetitive, things that requires crunching of numbers, all these kind of things that machines are better at doing, we rather they do. So at a fundamental level, we know machines should do something and we should do something else. For example, we are good at doing conversation. We are good at doing collaboration. We are good at connecting ideas. We are good at looking at people's emotions, right? And this is not just a high-level idea kind of thing. It is because in terms of artificial intelligence technologies, it is really hard to create a machine that can do all this. If you want to have a machine that can collaborate with another machine and come up with ideas, it is absolutely impossible. But also it's very hard for us to figure out how to do that. So fundamentally, it's hard for machines to do that. Whereas for you, for me and you, when I go over to my colleague and I ask him or her, what's the problem that you have? Can I help you out? That is intuitive. It's very easy for us to do. Fundamentally very hard for a robot to do that. Okay, so we know there's a delineation between the two. And we want to automate. We want to make the stuff that robots do well, they do that part. And another push factor, right, is this. Okay, when is the last time you used the comfort hotline number? Right? Is what I want to ask you. So you remember there's a number for the comfort hotline, I think 655211111, is it? I think that's what it is. I think for the most of us, we don't use that number at all now. Why? Because we now use the Comfort app. So this is the movement for coordination. It used to be towards human beings. So there used to be operators manning the phone. But now software is moving towards software. So software is controlling things. So it's moving towards the right-hand side. Okay, the reason is because if you use an app, you have GPS and so on. So this information can allow coordination and control in a better manner. And also in terms of scaling our organizations, last time we used to have more and more human, like in the industrial age, right? So if you want to scale, like for example, I have one factory building one thing. If I want to double my company output, I just have two factories, for example, and hiring double the number of people. But this kind of scaling using human beings is not possible because we don't have enough manpower as well, right? And also it's very scary when the economy go down, then after there's a lot of retrenchment because you scale totally through human beings. It's very scary that way. It's not very robust when there's a contraction of the economy. So now they are moving towards bots and automation as well. So there is a push factor for us to use technology in order to do things, to automate things. So we already see this in businesses. So the question then is, why don't we automate everything? Let's think about it. Why does your company, your current company as it is right now, why is not everything that is repetitive and stuff that you do not want to do? Why isn't it already automated? Is there a fundamental reason why? So let's do a thought experiment. Let's think about something here. Okay, let's create an app for our own company that does everything. So everything that's repetitive, we push it to this app of everything, right? So invoice processing, very mundane and boring and very repetitive. Let it do. Data entry, proposals, whatever that is repetitive, we get this to do. So how do we create the app of everything then? Well, one thing that we need to do is to have the systems to talk to each other, right? So that we can automate between them. So for example, if I have a customer relationship management software, I need it to talk to my own portal inside my company, which is a customer web application, and the HR management system that I have. I need them to talk to each other because the processes that I have requires data from both sides, right? All the data from each side. But the problem is that this software do not talk to each other, right? So if I want to create a software of everything, I don't have access to all this software. So how do I do this? If the software don't talk to each other, then I can automate all my tasks, right? Isn't it? So this is one problem that we have. So what this usually means is that when you try to adopt technology, you find yourself having a human being as the liaison between two different systems, right? For example, you have an Excel spreadsheet, you copy and paste into a web form that your company has. Does it sound familiar? Of course it does. Why can't that Excel spreadsheet then, be connected to the web form? Well, because something generated the Excel spreadsheet and that something don't talk to your web form, whatever the system that is generating the web form, right? So systems do not talk to each other and there's no glue between them. And so the human being have to do this mundane repetitive work, right? So it's pretty tough for us to do this app of everything. But wait a minute, there is an approach to solve this. So the approach is called creating APIs, okay? So APIs, right, are gateways that allow systems to talk to each other. So you might have heard about API. So don't be afraid by this time. It's just a way for you to enable different systems to be able to communicate with one another so that then you can make them automate things or do things in collaboration with each other. So you will be thinking, so now we can do our app of everything, right? So why don't we do our app of everything? So you'll be going, so problem solve. Well, we can do this, but not exactly. Let's see what it takes for us to create an API. So if you want to create an API for your company, you have to create a customized software, right? So you want to create APIs make everything linked up and create your app of everything. You have to start with business analysis, check what's the requirement, check what's the outcome that you want. Then you engage a system integrator or programmers to do it for you. They will create for you a software architecture diagram. And then finally, they will develop for you. You have to test and you have to deploy. And then finally, you have your software that you want. And the whole thing that you saw just now can spend many, many months, sometimes years. And the cost of it could be in the hundreds of thousands of dollars or millions of dollars. Now, the question that I have, if you are a manager and you are tasked to do this, would you want to have the burden of taking this risk? Well, the answer is no. The problem is that if we have to spend this much money and this much time, it becomes very hard for people to shoulder this risk, right? So, and that is why it is very hard for companies to automate, because the project is going to get very expensive very fast. And that is why we still do very monotonous, boring work that makes us feel like not working every day, right? I mean, this is one problem that we have. And now we can see what the root cause is. And there lies the genius of RPA. You know what RPA tries to do? Well, RPA sees it this way. So instead of me trying to look at your software, for example, your CRM or your HRM, your HR management system, your customer relationship management system, and then your web applications that you have inside your companies, Instead of building APIs, make them talk to each other and then automate stuff between them, instead of doing that move where it is done in the software level, you go to the software and then you edit it, right? This is extremely expensive. Instead of doing that, what Rpa tries to do is that, wait a minute, I realized something. The guy who has to do it, whatever this thing is, let's say if I don't automate all these things, right? The guy who has to do it, he's a person. He's a person that's sitting down on a chair and he's on a table and this is his laptop, right, in front of him. He has to use his hands. He has to interact with the keyboard. He has to interact with the mouse. He has to do everything manually. So the idea is the repetition happens here at the human being level, at the laptop level. So if it's very hard for me to do all the automation in the back end at the software level, what if I can just get someone else to do his work? What if I can get a robot, but not a physical robot, not like a R2D2 or C3PO, right? But instead a software robot inside the computer that takes over this guy's keyboard and mouse and do the work for him. Isn't it a very smart idea? The idea is that instead of trying to fix it at the software level, we give an assistant to the human being to do the repetitive task. And because unlike the software level, you can tell what you're doing every day, right? You can say that step 1, I know what I'm doing. Step 2, I know what I'm doing. I can just tell the robot to do those things. And from doing that, I got a robot that can do the repetitive work. So the genius of RPA is that because now you don't have to try to change your whole software, you just have to buy a bot and then tell the bot what to do. The cost can be very low. And then the implementation can be really quick. So you just teach it what to do, it does it for you, and then you pay an annual fee for the bot. The risk has been dramatically reduced. And that's the genius of RPA. Okay, so that's why a lot of organizations who want to try to automate, they try to use the RPA approach because the risk is so much lower and they can see results almost instantly as soon as they create the first bot. Okay, so that's RPA. It's about having a bot residing on the laptop, taking over your mouse and keyboard and doing things for you. Instead of writing a software to automate everything, it resides on the physical computer. So you get one bot for every single worker, and then everyone can use this bot to automate repetitive tasks. Okay, so we'll do a demo later, so not to worry. Okay, let's look at this video.
So I say the word innovation and you immediately think, the pulley. Wait, what? Stay with me. Let's go back to around 25 BC. Archimedes of Syracuse. Major big brain dude. He had this incredible idea. Here's how his buddy Plutarch reported it. He said Archimedes moved an entire warship using pulleys and his own strength. That is innovation. Not 2.0 or an upgrade or the next generation, but something that changes the way we think and work and live. The heralded breakthroughs have more often than not merely walked to the edge of innovation. The cloud and AI and low code. Complex problems can only be solved by solutions that don't cause more problems. So what would Archimedes do today? He'd build a pulley and call it Robotic Process Automation. Make the tech learn the human, name the task, name the workplace. RPA allows companies to automate at the UI level, connecting disparate technologies. Granted, that's a really wonky sentence. All it means is this: you and your employees can now pull vastly more than your own weight.
You can see how ingenious this ad is, right? It is trying to tell you that, if you come out with AI and stuff like that, like big things, you are complicating things. So why not do something like a pulley, something very empowering to that individual? Because with a pulley, an individual can pull more than his weight. So in the same way, if you have RPA, you give it to that person can pull more of his weight. And in fact, he can innovate and get the bot to do things. So the idea is they're trying to say, let's do an elegant way to solve the automation problem. Let's not try to build big things. Let's empower the user, that person. So you can see that how the empowerment of the person really resonates with all of us, right? And that is why RPA is very popular. Okay, I will not show this to you. because I'll show you the demo myself later on. Okay, so the idea is that RPA improve the employee experience. The reason is that it creates meaningful work for the employees. So 66% said RPA restructures existing work and make them have more human interaction. It improves customer service and delivery, because when you get a bot to do things for you, the chance of error is lower, and it automates role effectiveness. RPA helps employees focus their attention on meaningful strategic tasks. All right. Okay, so now that you know somewhat what RPA is, I want to show you a demo of what RPA is first. So this is the next step. And then after that, we go into this thing. This thing is very important. The idea of how RPA interacts with AI. And that can cause a very big change in the way automation will look like in the future. But before that, let's dive into an example of how RPA looks like. So the software that I chose to use is the market leader right now. So in Singapore, the brand probably that is pretty big is Uipath, and also globally. And I want to tell you something. When you look at the software for RPA, right, the way they designed it is in order to enable that person, the individual. So can you imagine, how do you program the bot? Do you think you have to program it using coding, or is it in a way that is simple enough for anyone to use? So obviously it's the second one. So how do they made it happen? So let me show you. So this is an example program in RPA, okay? And I want to show you something. Can you see that you are actually looking at flowcharts? For example, there is a flowchart here that says open Microsoft Excel, and there's another one that says open browser, go to this website, and so on. So the way it works is called the low-code manner, in which you program using flowcharts instead of writing lines of code. So in this manner, it's pretty easy for you to learn RPA, because you don't have to learn how to code. But when you go further, and I'll show you later, you do need some coding concepts, because in each of every box, the box that you see here, there are certain concepts in coding that you have to learn. So while you don't have to learn how to know how to do programming, certain concepts in programming is necessary for you to create the bots, okay? So, but first, let's look at the problem itself. So what problem are we trying to solve, right? I mean, that's the question. Let me show you. So this is the problem that we have. It's called the RPA challenge. The goal of this challenge is to create a workflow that will input data from a spreadsheet into the form. I think we've done it many times, right? Where we have data from a spreadsheet that we need to fill it up into a form. So I downloaded that Excel file. You can go to this page also, rpachallenge.com. Okay. And let me show you what's inside the Excel sheet so that you can have a look. Okay, this is how it looks like, right? So you can see there's the first column, first name, second column, last name, and so on and so forth. There's just a bunch of data, right? And what you have to do is fill in all these fields into the form. So what we will usually do is, for example, I put it on the left side here so that you can see it. And we will fill it in, right? Just to have a feel of it, let's just fill one. So for example, John Smith, email address is, let's say, jsmith. Oh, we don't have to do that. We have to copy and paste, right? Okay, we can copy and paste. That's fair play. And let's say all this like that. Role in the company is, he's an analyst. And the company name is IT Solutions. And finally, the phone number is this one. Okay, the trick is that when you click submit, right, they will change the format. So they want to tell you that, okay, you got to be smart enough to know where to put it in. So they keep jumbling things up and putting things at different places. So when you finish doing this, they will finally tell you what's your score right at the end. Okay, come on. So because maybe I'm not filling anything up, they're not giving me a score. Yeah, so I probably have to fill up because it's all empty. So now let's say if you want to create a bot that does this for you, then how does it look like? How do I create a bot? So it looks like this. So what it says here is the bot name is RPA challenge. The command is just something that you want to write at the top to tell you what this software is about. Next, The first box here tell you, I'm going to open Excel, right? And I'm going to open challenge.xlsx. It's the Excel file just now. It's this one. It contains all the data I want to use to populate the form later on. Okay. So pointed to that form, to that Excel file. And what it says is that, hey, read the first table called sheet 1. And this is a bit the part where I told you about, right? You need to know a bit about programming, just a little bit. So it goes something like this. It's saying, look at the data in the table, right? And put it inside this thing called RPA challenge string, right? And for every row that is inside, you put it inside a list. So what it means is that for every row is an individual person, right? So for every row, you do this. You do the following. So for every row, you do the following. You open up the browser and fill in the first name, fill in the second name, then type last name, type company name, type role in company. Understand, it's trying to take control of your keyboard and type it into the field. So you might be wondering, so what is this image not available? What are they talking about? No, they are talking about where in the form to look for. So where do I type it in? So they normally will have a preview of the image, but right now it's not rendering. But normally it will show you where in the form you have to look for. Okay, and finally, after you fill up all the text, then do it again. Loop it one more time for the next row, then the next row, and then the next row. So keep on filling it in. But before you go to the next row, of course, you have to click submit, right? Because there's a submit button at the end. So at the end of it, you gotta click the submit button here. Submit button over here. All right. So that's how the bot looks like. So I want to ask you, is it overly complex? I know that you haven't learned this software, but does it look overly complex? It doesn't, right? You can even like read and sort of understand what it's trying to do. So that's the idea. You can do it, but you still have to know a bit of coding concept, because you can see that here, row 0 means that the first column of the row. Row 1 means the second column of the row is the last name. Then row 2 means the third column of the row. So you have to know these concepts in programming. But by and large, it's not so difficult to create a bot, right? And once you create this bot, you can use it forever. That means if you have more of this data entry task into the form, you don't have to do it again. You just have to create it once and you are good. And that's the idea. So let's try to do this challenge right now. But in this, for now, we don't do it manually. We do it using the robot. So let's see what happens. We press play and I should see a prompt. Okay, hang on. The Excel is open. Let me stop. I gotta close Excel first because I opened it up just now for you. Hang on. Okay, let's try again. So they open up the browser, Chrome, and I should see a prompt coming out. Okay, this is the prompt. I know you can't see it because my resolution on my screen is too high, but it's saying, how fast do you want to run this? Do you want to run it slow, fast, or superhuman? So I want to try fast. Okay, so I use fast. Click. Okay, before that, I want to zoom in like this. Hopefully it still works. Click OK. And you can see that it fills in the form. So what's happening is they are taking over my computer to do all this work. Instead of trying to automate it at the back end, it does it right here. So it works. Okay, let's try to do it again in the superhuman speed. So I want to tell you that actually it's pretty quick. It's not that slow. It's just that they are slowing it down so that we can see. Okay, let's just do it one more time, superhuman. Okay, so we'll try superhuman. And this time the delay will be lesser. And yeah, you can see how fast it is, right? Very quick. Okay, so this is the power of RPA. And the real power is just not the automation, but the philosophy of it. The idea is that they want to empower that individual person, that you and me, we learn how to do this flowchart programming kind of approach, learn a bit of coding. And then after that, we can automate our own task and then share it with our colleagues. And then before you know it, all the tasks that is repetitive, you can solve it one by one, and then you can get more productivity. So isn't it like at the heart of it a very wonderful idea? I think it certainly is. Okay. So now that we really understand what RPA is all about, right? Let's understand what's going to happen in the future of RPA. Okay, so let's go forward here. So let's start by watching this video.
Automation has been embraced by people far and wide. Robots have helped people, unburdening them from dull, repetitive work so they can do the work that's worth doing. This has made people love the robots. And this love of robots has made RPA the fastest growing enterprise technology on Earth. It's also made the people want more robots. But not just any robots. They want smart robots. Robots that can do things like looking through invoices, making sense of sales notes, or reading endless contracts. So they want robots to have smart skills like reading, listening, and even holding a conversation. And they want collaborative robots that can pass tasks back and forth smoothly. So the robots do the routine and the people can handle the exceptions. Robots with a sense of rhythm. They want robots to automate any process possible. But the people need help to figure out which processes to automate and how to do that. So it's AI to the rescue with task mining. And more kinds of people want robots. Non-developer, business-type people want robots. They want robots that are easy peasy to use. Some of them might even make their own. That has to be easy peasy too. And to take advantage of all the good automation ideas of others, the people want a place to post and share their robots. Finally, the people want to be able to prove to Glenn in finance that the robot investment is paying off. So they want to measure the robot's work and provide performance insights, and then generate reports to explain how much money RPA has saved their organization. Glenn is always happy to see a good return on robots investment. The Uipath platform for hyper-automation. It's the world's only comprehensive RPA platform that gives the people what they want, from discovery to measurement and all the wonderful robots in between.
You really did it well, right? The way they message this. I mean, firstly, what I wanted to point out from that you saw just now is the idea that they wanted smart robot, right? You hear that? They do not want robot that is not so smart and can do only very simple things. And it is really true, So right now, what I want to tell you is that RPA and AI is something that really fit to each other like a glove. It's a technology that complement each other really, really well. So in order for us to really appreciate this synergy between RPA and AI and the implications that it has in the future, you need to really understand what machine learning is. And I have a very compressed version of what machine learning is that I'll cover in the next few slides so that you understand what it is. And then we'll look back at what is the implications of that in the perspective of RPA. All right. So it'll be nice and fun for you to learn this as well. So machine learning is an approach to achieve AI that has been given much attention today. So the idea is that you've always heard about AI. AI is an umbrella term which says that, so when you hear about AI, it is an umbrella term about anything to do with making machines smarter. And the idea is within AI, there's something that is called machine learning, ML. And it is a part of AI. But if you hear the news that AI did something and something, right? Chances are what you're hearing about is machine learning, because machine learning is the branch of AI that is getting a lot of success. All right. So let's understand what machine learning exactly is. Okay, so we'll do a very simple example, right? Okay, let's create an AI that helps a robotic arm catch a ball. So for example, if you want to create some kind of AI that can look at the trajectory of a ball, they have to figure out this blue line, right? So when you throw a ball, the input is this red line, how much force is being thrown. The robot has to figure out this blue dotted line and then try to catch the ball, isn't it? Now, how do we figure out that blue dotted line so that we can catch the ball in midair? How do we do that? Well, in this case, it's pretty easy. You know why? Because we can have the input being the velocity and angle of the ball being released. And then we need some kind of mathematics, right, to crunch those numbers and then tell us how the trajectory is. And then we can catch the ball. So what we need is, the point of this slide is to say that what we need is mathematics. We need mathematics. We need some guy, some smart guy, some scientist to tell us what's the mathematics that link the input, which is how the ball is thrown, and the output, which is the trajectory of the ball, so that I can get my robot to catch the ball in midair. You got it? And in this case, can we do the mathematics? Of course we can, because there are laws in physics that govern how balls will move in midair, right? It's Newtonian physics. It's our Newton physics, right? We know this. So in this case, we do not need machine learning at all, because we have people who can write mathematics in order to solve this problem. So we get AI, but we don't need machine learning. All right. So that is called the traditional method of intelligence, where you have someone to handwrite mathematics in order to solve something, right? Okay, so then what is machine learning? Well, the problem with the traditional approach is that, let's say I ask you a simple question, and this is a problem that we had in the past that we couldn't solve so easily. So before machine learning was blooming right now, in the past, we couldn't solve this that easily. So let me show you what I mean. If you do object recognition or image recognition, let's say you put in a photo and you ask the person, hey, what's in the photo, right? So for example, you have a photo of a cat, right? And then you ask the machine, tell me what's inside this photo, right? What's inside this photo? And the machine will struggle. You know why? Because how can you, if you use the traditional method, how can you get a guy to write the mathematics to describe what's inside the photo? It's too abstract, right? How can you describe something like a photo? What multiplication do you use? What kind of mathematics do you use in order to try to figure out what's inside that photo? And that is the problem. So some things such as image recognition is too abstract for you to handwrite mathematics. And a lot of things like this is. And so when you want to do RPA, a lot of things that you want to solve falls into the category that is too abstract for you to write mathematics for. Okay? And this is where machine learning thrives. Okay, let me show you this video. Okay, hang on. So she explained this problem in a very nice way. So you can listen to it. It's a TED Talk. So I really love the way that she explained this problem.
Ultimately, we want to teach the machines to see just like we do, naming objects, identifying people, inferring 3D geometry of things, understanding relations, emotions, actions, and intentions. You and I weave together entire stories of people, places, and things the moment we lay our gaze on them. The first step towards this goal is to teach a computer to see objects, the building block of the visual world. In its simplest terms, imagine this teaching process as showing the computer some training images of a particular object, let's say cats, and design a model that learn from these training images. How hard can this be? After all, a cat is just a collection of shapes and colors. And this is what we did in the early days of object modeling. We tell the computer algorithm in a mathematical language that a cat has a round face, a chubby body, 2 pointy ears, and a long tail. And that look all fine. But what about this cat? It's all curled up. Now you have to add another shape and viewpoint to the object model. But what if cats are hidden? What about these silly cats? Now you get my point. Even something as simple as a household pet can present an infinite number of variations to the object model. And that's just one object.
Yeah, so you can hear that, right? So basically, the problem that we have is just a simple object such as the cat is already so difficult for us to solve, right? Using mathematics by just trying to figure out the shape or geometry of the object. And so how do you do it? You can create the mathematics. How do you solve it? So this is where machine learning comes in. So the way machine learning works is that instead of trying to write the mathematics using smart people handwriting the mathematics, what you do is you use data to write the mathematics, using data to write the mathematics. So how does that work, Isa? So in the next few slides, I'll run through with you how it works and why it became so big right now. Okay, it became very, very big now. It looks like this. So you have to define two things. You have to define input data and output data. What does it mean, Isa? So that means what do you want to put into the machine, which is called input data, and what you want the machine to tell you at the end, which is called the output data. So in this case, I want to input to the machine the photos, right? So that means I want to tell the machine this, I want to give the machine a picture, one of these photos, another one of these photos. And what do I want the machine to tell me? That they are airplanes. So this output. So you have to collect this. So that means you literally have to teach the machine. You have to take a bunch of pictures and label them, what's inside, and then you label them one by one. So this is called a data set. When you have a bunch of data with both the input and output, that means you do it to teach the machine. So what you do next is that you teach the machine using those data. You put in a photo, and then you ask the machine to guess what's inside that photo. And then if the machine got it wrong, it will correct itself and do better next time. So maybe I'll run it through with you in a slower example. So I have some slides ready to go through in a slower manner so that you can really understand the concept of how you train the machine. So this is how it works. Okay, let's say we are in a situation where we want to create a machine. What the machine does is that it will try to look at a certain customer, a tenant, and then it will take a house. For those of you who are house hunting now, you'll like this example. And it will try to figure out whether a tenant will like a house or not. So the input is tenant information, like let's say the tenant's name, Jack, the age, the height, the favorite color, the amount of family members that they have living in the house, and so on. So tenant information. And then the next one is the house information. Where is the house located, right? How big is the house, and so on, decor. So these are the data that you have to collect, the first one. Then the output data is within 0 and 9, whether that person liked the house or not. 0 meaning the tenant hates the house, 9 meaning that the tenant loves the house. So what you got to do is you got to go to every one of your tenants and then ask them, do you like your house or you don't like your house? It's a survey, 0 to 9. So what you're left with is this set of data, right? So you have input data like the age of the person, the number of people in the house, and the floor space of the house, and so on, right? So information about the tenant and the house. I'm just giving 3 examples here. Then at the output, you have a stack of data which says 0 to 9, okay? Then what you do next, right, is that 70% of the data, about 70% of the data, you use to make the machine smarter. 30% of the data, you don't use it to make the machine smarter. What you use it for is to test the machine on how good the machine is. So how it goes is like this. So a lot of people will ask me, Isa, why would you want to waste 30% of the data to not make the machine smarter? Why not use 100%? And then the machine will be extremely smart, right? That makes a lot more sense. Well, the reason is that if you use only 100% of the data, the whole thing, to make the machine smarter, then how do you know how well the machine does? And then if you use the machine, then how do you know how well it can do? Isn't it very risky? So for example, in this case, let's say you use it, you match the wrong people with the wrong house, and then it will cost you a lot of loss, right? So that's the problem. So the act of testing the data, having testing data to check the model is just as important as training. Okay, so this is how it works. So for example, the first data that comes in, let's say the person's name is John, right? So John is 30 years old, and maybe John likes the color blue, let's say. And John, for example, has a family of 4 staying in that place. John likes modern design, and so on. So this is from your survey, all right? And then next, the house information, okay, the house information. The house information, maybe the place is in Clementi, and let's say it is 500 square foot, okay? And maybe it is country design or whatever. So just a bunch of data about the house. And then this machine right now is very, let's say, quote unquote like dumb, right? It's not taught yet, so it's a dumb machine. It's just empty machine, right? It doesn't know anything. So the machine will then just guess whether John likes the house or John do not like the house. So the machine will spit out, let's say 7, I think John loves that house. But we know because we asked John, right? So John told us, no, I completely don't like the house. So I hate the house. 1. Now, this is the next very important concept. In order for you to do machine learning, you would have to have error. So error is how far off the machine got it wrong. So in this case, it is 7 minus 1, which is 6. So 6 is the error. It got it pretty off, very wrong. So what you then do is you can imagine the machine here as like a malleable piece of metal, like something that you can form using a mallet. And what you're doing is that you are having a big mallet, and the more the error, the harder you're hitting the machine with the mallet. And what you're trying to do is to shape the machine into the formula that solves the problem. So you can imagine that the formula is a shape that you do not know, and then you're using a mallet to shape it into the formula. And what tell you what the shape is? The error. When you got it wrong, that means you got the shape wrong. So you got to correct it. Okay. So you keep doing that. Let's say if you have 100,000 data, right? You keep doing that. Data number 2, data number 3, data number 4, data number 5, all the way to your 70,000 data, because you're using only 70% of the data, right? The 70,000 data, okay, we have the next one. So let's say it is Susie. So Susie is 50 years old, and she likes the color purple, let's say, right? And so on and so forth. And then the house information, the house is in, let's say, Hougang, right? Hougang. And it is 1,000 square foot. And it is modern design and so on, right? So then after that, we ask the machine, is the machine empty now? Is it dumb now? It's not, right? It's very smart because you hit it 70,000 times already. This is your 7,000th time. So it now sort of have a good feel of what is the answer, right? What is the formula? So what it does is that it will spit out a number, and the number, it thinks that, yeah, I think Susie will really like the house, 9. And in fact, the answer is, because we asked Susie, the answer is 9. So the error gets smaller and smaller as we hit the machine more and more and get to the shape that we want. So the punchline is, machine learning and AI is an approach in which you use data to create the mathematics by knowing how much error to correct it by. So by knowing how much error to correct it by, you're creating the mathematics by hitting on the model like that. So this is machine learning, and it's able to create mathematics that humans cannot write. The kind of mathematics that they write here is not the beautiful E equals to MC squared, right? You know how this looks very pretty? Or F equals to MA, right? You know, all these kind of formulas that we know from Newton's law, right? And the kind of beauty in this formula is that it is very elegant. It's short, but its implications are big. It can describe so many things. In just a small equation, it describes huge amount of things, right? So that's the idea. It's elegant, but not for machine learning. Machine learning, the mathematics inside here are pages and pages of very messy looking mathematics. And this kind of mathematics is perfect to be able to describe things that are more abstract, such as what is inside that image. Okay, and this is the breakthrough, because this is the idea of what AI is. It enables us to solve things that we could not solve before. So what does machine learning training means, right? It's the process of coming out of the formula inside the box. So a lot of you may be asking me at this point of time, Isa, before we go back to RPA, right? I think a lot of you might be asking me, Isa, what's inside that box, right? Is there any way for you to tell me what's inside the box just now? So in order for you to really understand what's inside the box, I can show you a work from, I think, a scientist, and he visualized what's inside the box, and I think it's very pretty and very intuitive. So I'll share it with you. So in order for you to understand what he's going to show you, let me explain to you what you're going to look at. So the first is the input. The input is the images, okay, of handwriting of numbers. Can you see this? It's 0 to 9, right? Different people writing 0 to 9, handwriting. So the input is small little images of handwriting of digits 0 to 9. Okay. The output, what the machine has to do is to recognize that image and figure out what the number is. Is it 0? Is it 5? Is it 7? You have to figure out what the number is. Okay. So input data is handwriting image. Output data is the label, the number. What's the number? So someone has to do that labeling and teach the machine. All right. So it looks like this, right? So you're going to teach the machine. So for example, you put in 5, you want the machine to say, it's number 5. Okay, let me show you one work. I mean, I want to tell you that this is the ABCs of machine learning. So one of the first AI that you create when you learn AI is this one. So let me show you. It's called MNIST dataset. You can see that when he write 2 on the mobile phone, you can see the result here is 2. The machine is saying that the number is 2. And the probability is that I'm 99.99% sure that it's correct. Just like that, just put in, write a number and the machine will figure out what the number is. So the number is over here. Maybe it's too small for you to see, but the number is at the result here. That's 5. Okay, now that we know what the MNIST dataset, this problem is, let's go to the what's inside that box. I think that's more interesting. So what is inside the box, Lisa? So what exactly is this AI thing that is inside, the mathematics that you're talking about? How does it look like? So let's have a look. So it looks like this. Okay, I'll talk you through what it is. It's very interesting. I think a lot of you will like this. So what you're looking at is number 0. Can you see the number 0? Can you see number 1? Yeah. Can you see number 3? That's 3. So as you might guess, what you are seeing is the pixels of the image of the number. So the input is the handwriting, right? So this is the pixels. Each white pixel is the handwriting. The black pixel is the background, the white background. They are putting it the opposite way because in convention today, when you have a number, white means ink, like there's a value. Black means 0. There's no value. So that's why you see it written in white rather than written in black. So white means a value. Okay. So anyway, so this is number 9, this is number 0, and so on. So what are these numbers connected to? What are these pixels connected to? They're connected to a bunch of dots and lines, right? Like, have a look at this. It's a bunch of dots and lines. Not unlike the brain that we have, right? We have neurons that are connected to each other. They are dots and lines, right? And what they are, right, is actually addition, multiplication, and some non-linear function. I know the last one sounds a bit scary, but it's nothing much at all. It is just a set of functions that is non-linear. That means very complex for human beings to use, but machines can use it, right? Non-linear functions. So what they try to do then is they put all the pixels into the bunch of mathematics inside the pages and pages of it. Can you see how many dots and lines you see? That's the mathematics that they created. And at the end of all that mathematics, right? Okay, by the way, when you see it being white, it means the number is big. That means the addition and multiplication and so on is excited. So the number is big, it's white. When you see it's black, it means it's not excited. In other words, you're saying that that part of the pixels are not important to determining what is the outcome at the end, what's the number. Okay, so you can see it being excited or not. Okay, what is happening here? It's guessing. I'm guessing the number is 0. I'm guessing the number is 8. I'm guessing the number is 9. I'm guessing the number is 3. Can you see that? It is the input is the pixel, in the middle is the mathematics, and the output is what the number is. So when you are doing the training, the data, what you are doing is figuring out the middle part, this sandwich, the dot and lines part, the brain part of it, right? How much to use for each, how much to add, how much to multiply by, what are the different things that you want to tweak in the middle. You are figuring out the mathematics for the middle side here. So they call it the weights in the middle here. You got it? So the data is used to figure out how much to add, minus, and do the non-linear function in the middle here. And that is why it is reminiscent of our brain, right? Our brain have neuron and synapses, similar things. They shoot when they are excited, right? Same thing. But I just want to make a delineation. So this thing is called artificial neural networks, but in real life, it is not as complex as our human brain. There's just a lot of similarities, but it's not exactly the human brain. The human brain is far more complex than this. I mean, if it's as easy as that, we would have created an artificial human by now, but we don't. But the idea is that it's very inspired by the human brain. And so it is called artificial neural networks. Artificial neural networks, or artificial brain, right? Okay. So now that we know what is the technology behind all the successes that's happening right now, the question that you have now might be, so why is it successful now? Why is it not successful like a long time ago? Or why it's not successful later on? Okay, the reason is in two parts. And I want to tell you that the question is a very good one, you know. It might seem like a normal question, right? But it's not. It's actually quite a good question, because the technology that you saw just now has been around in the 70s. That means the paper that wrote about neural networks was published in the 70s, I believe. And we didn't have a lot of success in neural networks. I remember back then they were saying neural networks was a bit of a flop. It didn't really create anything that the hype was about. And then out of nowhere, I think in the early 2000 and so on, it started, or not early 2000, I think later part of 2000. Then after that, there was some successes and it just springboard up, you know, suddenly we can do a lot of things. You know why? Because of two things. One is data. So back then, very few data that's available because everything is analog. They are not digital, right? They are not digitized. So a lot of data is not available for you to train the machine learning model. The second reason is that computing power. You know the hammering that I spoke to you about just now? It sounds like an easy thing to do, but it's not. It requires a lot of computing power. I have one of the fastest machines that you can buy, for example, like a consumer machine. And people ask me why I do that. It's not because I do gaming, it's because I train machine learning models, right? So when I do research, I had to do that. So you need very high computing power in order to do machine learning training. And it was just not possible back then. So one thing that you also know, that look at data, and this is an important punchline. Going forward, data is increasing exponentially, right? There's just more and more data that's available for us today than in the past. It's just going to increase more in an exponential manner. In terms of computing power, although we are not increasing in an exponential manner anymore, but we are still increasing very quickly, right? It's not a linear manner, it's still quite fast. So computing power is going up. So what can you tell about the ability of AI in the future? What you can tell is that AI is inevitable. There's nothing that can stop it because data is increasing and computing power is increasing. There's no way to stop the idea that AI is going to be very big in our future. Okay, it can do more and more things. Okay, now let's get back to RPA. So you'll be thinking, Isa, why are you talking about AI? And because we're here to listen to about automation, right, in RPA. The reason is that RPA and AI fit each other like a glove, you know, in a hand, like what I said earlier. And you'll see later why. And that is why the success of AI will affect the trajectory of how RPA is going to be used in the future. So let me show you what I mean. Okay, so you can have a look over here, right? Okay, let's say when we have a situation for me. I receive a proposal for a new course, right? And the first thing I'll do is, okay, I'm making a hypothetical thing, right? Okay, so for example, I'm a film director. I'm a film director. And I receive proposal for films that I should direct, right? So the first thing that I'll do is I'll do rule-based stuff. I'll check whether the film is within budget that I can do. Okay, I'm a producer, sorry, the wrong word. I think it should be a producer. So I will check whether the film is within budget that I can do, right? I'll check whether the film is by, let's say, the local actors, because maybe I'm for the local market, and so on. So these are rule-based stuff. That means I can check in a systematic one-by-one manner, right? Okay, so this is rule-based stuff. But how about at the end, I have to read the script. I have to read the script and check whether the movie is good or not. Can I do rule-based stuff for this? Absolutely not. I need to read the script and then I need to check whether that movie is going to work or that movie is not going to work, right? So this part, I need human judgment. I need to read the script. and I need to check whether it'll work or it will not work, right? So this part will be RPA, take a proposal and so on, RPA, and then RPA will send it to me, and then I will tell RPA what I think, yes or no, and then after that, RPA will take care of the rest, maybe sending over to someone else and so on. But in between, I need to do it, right? So that's the human judgment part. Okay, let's think about AI. So what does this mean? Think about it. Wait a minute. So if you think about it, this part that I'm doing, right? Isn't it like the AI block that we saw just now? Isn't it? So it's like machine learning block, and I got input data. The input data is what? The script, right? And what's the output data? The output data is yes or no. Yes or no, or maybe 0 to 10. Maybe how good the script is, maybe how good the deal is, 0 to 9. Okay. So at first, this machine learning model cannot be taught because we got no data. But as me, I go through 1 example, 2 example, 3 example, maybe my colleagues all going through all the scripts that's available. Before you know it, I have thousands and thousands of scripts and our review and our decision of how good that movie is. And then what can we use that data for? Well, we can use that data to train a machine learning model. And then that machine learning model will get smarter and smarter, right? So instead of me coming out with the rating, the machine learning model will tell me, Isa, yeah, this one is 7, or this one is 5. So isn't it amazing? So RPA, because it takes care of the data, it's taking care of the data coming into the box and taking care of the data coming out of the box. It becomes a very good candidate to fit machine learning models with data in order to train them. So it's a very powerful idea. So right now in RPA, Uipath, Power Automate, and everything, a lot of RPA solutions out there, they are capitalizing on this. What they know is that because they are taking care of so many processes, a lot of the data that is flowing through them can be used for training machine learning models. And this is a very powerful idea. So now suddenly you don't only automate simple rule-based stuff, but rather you can do things that are much bigger than that, okay, through machine learning. So as machine learning gets stronger, RPA will get stronger as well. Okay, to drive this idea home, let's watch this video.
RPA and AI are better together. When paired, they can read, write, listen, and make decisions to work effectively. But apart, robots can only automate so much, and AI becomes hard to apply. AI needs RPA as the delivery mechanism to solve real-world problems. And RPA needs intelligence for its robots to learn new skills, like visual understanding or process discovery, or understanding natural language. At Uipath, we're developing a solution to pair RPA with AI that we're calling our AI Fabric. Uipath's AI Fabric is the connective tissue between these two worlds, delivering end-to-end AI skill creation and deployment within the Uipath Enterprise RPA platform. AI Fabric works by first giving you the option to either build your own AI skills or select pre-trained skills from Uipath or over 60+ AI technology partners. AI Fabric will allow you to deploy and manage your AI skills, then drag and drop them right into your RPA workflow via Uipath Studio. Finally, AI Fabric will close the data feedback loop, giving information back to your AI skills to continuously improve the model. With AI Fabric, RPA and AI will finally come together and help you take the next step on your automation-first journey.
So now that you have watched all the preceding content that I've shown you on machine learning, you can really understand what they are talking about, right? The video. I mean, you can understand better than most people, right? The idea that you can continually improve the AI as more data comes in. And then the idea that things that human beings cannot design, but AI can do because they create mathematics for abstract problems, as long as you have good data in order to solve those problems, right? So you can really appreciate the power that can come from this. Okay, I think I'll skip that for now. Okay, now let's have a look at an example of how this is done. Okay, one of the very big capability that we have today is on natural language processing for AI. So for example, when you look at resumes, right? So when you look at jobs, that you need filled and the resumes that are being sent to you. So last time you might have to read both, but now with natural language processing, we can tell how much of a match they are, right? But not all the time. Absolutely not all the time. A lot of things requires context. Sometimes it looks like the person is qualified, but they are not when the person reads it. Or the opposite thing, right? You might see that the person is not qualified, but if a human really reads it, they realize, oh, no, this person can close the gap and should be able to do it. So we know that is true. So that's the beauty of RPA. So instead of just using AI, when you use RPA, you can get a human being involved in the process. And also you automate the whole sending of the data to the person and up from the person in one technology. So let me show you this example. It's pretty neat.
In this demo, we'll see how Uipath robots can use AI to screen candidates for a job position in an HR management application. Based on the contents of the candidate's resume, the robot will decide whether that candidate is a good match for the position or not. To do that, the robot uses the Skill platform, which is offered by SkyMind and allows the creation of custom AI models. In the Activities panel on the left side, we can see activities used to interact with Skill, like Skill Deployment Scope, Classify Data, and Decision Learner. They are used in this workflow that reads the resume from a PDF and then transforms the data into a representation that the AI model can process. After that, the robot will classify the candidate based on the contents of the resume. And it'll output a prediction of what kind of professional he or she is, as well as its confidence level about that prediction. If the confidence level is lower than a specific threshold, the robot will request the help of an operator.
So what they're just saying is that the robot will check the resume, and if they are pretty sure that it's a good match, very sure, then no need the human being. But if they are sort of not so sure, then send it over to a human being. So let's have a look.
By using the Decision Learner activity, the operator can teach the robot whether that candidate fits the requirements of the job position. Finally, based on the prediction, the robot will shortlist the candidate or reject the application. Let's run the workflow and see how it works in practice. First, the robot opens and logs into the HR management system. It then checks the list of candidates and filters the applications that were initiated for the data scientist position. For each candidate, the robot accesses the page with the details and downloads the PDF containing the resume of the candidate. It saves the file and reads its contents. We can see here that we already have a strange situation. A farmer applying for a data scientist position. Well, this must have been a mistake. The robot understands that this candidate is not a good match for the data scientist position and automatically rejects the application. In the last step of the evaluation, it writes a note to indicate that this candidate was screened by a robot. The robot then moves to the next candidate, opens the details page, and downloads the new resume. Based on the contents, like education and skills, the robot understands that this is a data scientist, shortlists the candidate, and writes a note about the automatic screening. Now the robot will evaluate the last initiated application. The last candidate to be processed also has a technical background, but not exactly the profile of a data scientist.
So this particular resume has a technical background, but not a data scientist. So they are halfway there, not so sure.
Since the robot doesn't have enough confidence to decide, it will ask for the help of an operator. The operator can examine the resume and teach the robot if this candidate fits the profile of a data scientist. This new data is then used to improve the accuracy and the confidence of the AI model. After processing all candidates, the robot closes all used applications and finishes its execution. This demo showed how to integrate.
So it's very nice, right, isn't it? I mean, you think about it. I mean, the whole flow of handing over the resume to someone else, and it was from a HR management system, right? The robot did not integrate with the software. It did not. It logs in, pull out the data, and then, check whether it's a good fit. Not a good fit. As part of the RPA, it asks the human user to evaluate, right? It's as though you wrote a piece of software to do this, but you didn't. You use RPA instead. You got it? So the person who had to check the resume created this RPA so that he or she doesn't have to do it manually anymore. It's not some software that was created in the back end. It is software that is residing on your computer doing things for you, logging into your current HR management system. It's just a very beautiful idea. And when they are not sure, you tell them how to be sure. I mean, by giving the input, and then after that, it will improve subsequently. A very powerful idea. And so the Uipath, they have the AI center. So I'm not sure whether I'll play this, maybe not so necessary.
Once upon a time, there was a dark windowless room where a...
Okay, so the next part that I want to tell you about is, and I just will do this a bit briefly, is the idea of task mining. So this is something that is getting very popular now. It goes something like this. How do you know, okay, now that you know you can automate a lot of things, right? Okay, great, good. And I know that I can empower the individuals to do that. And I know that I can automate AI, using AI and do more meaningful work using the robot, for example. But the question is, can I use AI to figure out what I can automate in the first place? And that's the problem that task mining is trying to solve. The idea is that, can the robot look at what I'm doing every day? So I'm just doing my work, whatever I have to do. And then robot goes like, hey, wait a minute, you keep doing this thing over and over again. I think this I can do for you. If you think about it, they can do that, right? Because they can see your keyboard and your mouse movement and how you open software. So the machine can see patterns that what you are doing every day that is repetitive, right? And that is what task mining is. It's about looking at what you're currently doing and figuring out what tasks can be automated. So this is a solution. It exists now that you can use in order to increase the amount of work that is being automated, that is repetitive. So you want to remove all the boring stuff from your work, right? So they figure it out for you. Let's have a look.
Jasmine is on the hunt. She wants to track down the next great efficient automation opportunity for her organization. Why? Well, now that she and her colleagues have seen the success of their first automation, Jasmine is on a mission to make things even better for everyone. That means ensuring no one is left wasting their time on mundane tasks, and that her team and her bosses get more of those automations they want. The problem? It's all very confusing, using traditional manual approaches to try and find out how the work gets done, with no clear pathway. It's all a bit of a maze, actually, which means it's both time-consuming and expensive. Not good. And then, of course, it becomes super tricky to scale up automation programs with all this complexity. Surely there's a better way. And there is. That's where Uipath task mining comes in. Task mining does away with all the confusion, giving you clear pathways ahead by analysing the daily tasks of all the employees and scientifically identifying the best automation ideas. Now it becomes a cinch to scale up your automations too. Talk about exactly what Jasmine's after. Here's how it works. The first stage is all about collecting. Jasmine can share the desktop app with her colleagues to start automatically capturing their activities with no interruption to her work or theirs. With security and privacy features built in, she can capture and upload the data no problem. Next, it's analysing those findings. Artificial intelligence teases out frequent task patterns to provide Jasmine and her team with data-driven automation suggestions that drive the highest ROI. Finally, a practical use of AI that will keep everyone talking. After that, powerful visualizations automatically construct process graphs, so Jasmine and her colleagues can drill down into variations and frequent paths, including process replay. Finally, it's the export phase, where Jasmine can leverage the full benefits of the end-to-end automation platform and turn the discovered automation ideas into action by exporting her findings into Uipath Studio or as a detailed process definition document. Now, thanks to Uipath task mining, Jasmine is equipped with the knowledge of how work gets done and can supercharge her organization's automation strategy with the best automation ideas. Try Uipath.
Seems amazing, right? Isn't it? This task mining solution. So it is something that not only Uipath have, all the major RPA competitors, they have their own versions of it. And it is really a great idea. So this is basically in artificial intelligence, it's a problem of clustering and coming up with patterns from what they see. Okay, so I'll not go into here. Now we pivot. So now we know what the technology is. Now we know what is the implications in the future. And now we see the whole, why is the hype, right, around RPA? And now we really get a feel of why it is really a big thing. Okay, so we go back to Earth. We go something that is a bit more grounded in the next few slides. Because you see, we understand what the technology is, but how do people really implement the technology within a company? So I've gotten very familiar with the Uipath model of adopting, RPA within a company. And I suppose that for most brands, it will be a similar approach. And I want to share it with you. So in the next few slides, it's less technology and a lot of excitement kind of slides, but I want to share with you, like if you want to really put on RPA within your company, how does it look like? Okay, so let's get down to that. So the first one is the identification of what kind of task that is really have a lot of potential for you to automate, the automation potential of it. So there are repetitive processes are the best one. Rule-based processes is second, and then the structured processes as well, that are well-defined structures. So these are the three properties of tasks that you want, things that machines are good at doing. You probably understand what I'm talking about because we went through a lot of these just now. The other thing that you must understand also for RPA bots, right, there are two types. One is the one that runs on your PC, the one that I spoke about. It is installed on your PC and it's your assistant. That's called attended bot, attended. That means it cannot work by itself. It works with the human being. The other one is called unattended, where it has its own computer, sometimes without a monitor also can. And what it does is it does things on the background without the human worker. So that's called unattended. Okay, so typically in a company, you can have a combination of both. A lot of you might be asking me, so why would you ever need an unattended bot? Well, there's some things that happens in the background and you need a bot to do it for you. You don't need any human intervention at all. For those, it's better to have one dedicated bot so that it's not slowed down by the human worker. Okay, it is just doing things in the background. Okay. Okay, in terms of the implementation of RPA, it is something that you can't say, oh, only for finance or for HR or something. It is something that applies for the whole company. It is something that is horizontal towards the whole company, because in every department, there are things that are repetitive and it can be applied in every place. So for example, in HR services, processes like recruitment, payroll, finance will be procurement, order to cash, and so on. Okay, so it's not something that is specific to a certain department. It really isn't. And Uipath has created this heat map. It's pretty nice. You have a look. So for example, if you look at HR, so all of us are somewhat familiar with HR and HR technologies, processes, right? So for example, create HR strategy and processes. Develop HR strategy. Okay, let me show you what I mean. Develop HR strategy, identify staffing needs, okay? Training, recruitment and onboarding, create post-jobs description and so on. When you see it as red, it means it's not a very good fit for RPA automation, all right? If you see it as yellow, it means that it is medium potential. If we see it as blue, that means it's high potential. It's a very good fit for this. So for example, if you see creating HR strategy and processes, obviously machines can do that, right? So it is mainly red, right? But whereas when you look at things like managing employee performance, when you manage employee performance, manage compliance, time and attendance, and so on, there's a lot of repetitive rule-based work. And therefore it is blue. There's a lot of opportunities there. So this kind of heat maps shows you that in our typical role, right, there are a lot of blues and there's a lot of opportunities for automation. And RPA can help you with that. And also, one thing that I want to tell you is that while these things are red currently, if you talk about the far future, right, when, let's say, even if your company want to try to automate certain things that are yellow or red using AI, then it can be possible to still use RPA. but you have to be very surgical in the use of AI to make sure that you can automate those processes that initially couldn't be automated. Okay, so it doesn't mean red is red forever. It depends on how much AI can solve things that are not rule-based. Okay. Okay. Next, so these are some common terms in RPA that you have to have within within organization. So one big idea is called a center of excellence. It's something within your company that drives the RPA development. So it's like it could be a bunch of your colleagues as well, or people dedicated to this idea, but they help the company adopt RPA, because you cannot have different people to just know RPA, which is okay. That can be fine too. But if you have a group like a center of excellence, they can help give the expertise to people who are trying to create bots. Okay, and then you have certain documents that for the development of the bot, and then you have to process engineer, make sure your processes are optimized, and then lastly you create a proof of concept. Okay. The next one is the center of excellence. I think this is the important one that I want to share with you. So the Center of Excellence governs RPA deployment, standard best practices, and support the training of RPA as well. So it is responsible for the implementation of the automation project, and a central team that controls the working mechanism of RPA. And the way it's implemented is this way. You have a look over here. So within your company, right, one way to do it is to have a centralized center of excellence for RPA, which means to say that you have a dedicated COE to help people implement RPA. Well, you can do that. And then all the departments, all the business units use the COE. Another way to do it is for you to have different people within each of the business unit to create a COE, right? That means you train some people within your company, very department, and then get them to create a COE so that you have every business unit have some capability. So this is federated. The other one is hybrid, in between the two, right? One main RPA COE and link with smaller COEs everywhere. So this is I know that it is a big idea to implement in any company at all. It is. But at the same time, looking at the technology that you saw and what RPA is capable of, it could be something that's interesting if you can promote in your company to create a center of excellence, because this center of excellence will give rise to work that is repetitive, being removed from people's daily work, and it creates a much more interesting, I think, job and working environment for everyone. In an RPA team, there are, okay, for those of you who are thinking about learning about RPA, right, there are different roles in RPA that you can be a part of. So one of it is RPA developer, is the guy who is the person who have to create the bot, right? So the RPA developer develops the bot. The second one is the RPA solution architect. It is above the developer and create the structure of the RPA. And this is only when the company matures in the RPA development. In the initial stage, they can just create RPA and create bots in a simple manner. But as they grow bigger and bigger, you can imagine that the RPA needs to be maintained and needs to be taken care of. And you need all these structures, okay? And infrastructure engineer, business analyst to make sure that the business needs are being met by your RPA, project manager, and technical lead. So when you create an RPA bot, first you analyze what is your automation, what you want to automate first. Second, you start development. And then after that, you do testing. And finally, you do support and maintenance of the bot. So this is the typical task that you have to do in a company in order to implement RPA. And what do you want to achieve in RPA? And this is an important slide. It really is. It's something like this. Okay, so it's beautiful that you can create bots, right? But how do you know the bots really work or make things worse? The last thing that you want to hear is that you tell people that, hey, the bot we've created, right? But can you see bots are useless? You know, human beings are better because they keep making mistakes, right? This could be something of a deterrent for people to adopt bots because these are not taken care of. One is predictability in execution. Second one is standardization of inputs and outputs. And the last one is reducing the exception rate. So basically, it's about reducing the problems that are happening in the execution of the bots. So these are the process standardization. Okay, the last slide that I have today sort of summarizes the challenges that you have when you want to have RPA in your company. Okay, and this is, I think, for those of you who might have already adopted RPA, you might definitely have seen this. So the first one is, you can have a look over here, maintenance of RPA. Maintenance of RPA is costlier and one of the biggest issues, challenges in RPA and infrastructure. You have to take care of the RPA bot to make sure that it's ready to run. So you need to maintain it. Second is business case issue. Implementing successful RPA is a challenge that requires lots of approval and validation. So you need to have, you need to be able to have a business case to create the bot, and that requires a lot of approval and validation. Next is business IT collaboration, because RPA is very bottoms up, right? As you can see, it's from the business people who require something, and then they can do it themselves, or they can do it with an IT team. So they need to work very closely. So both business operation and IT bring specific value in RPA projects. So how to collaborate them together. The next one is weak governance. Many companies underestimate the work that has to be done for the initial automation, right? So the kind of support that you have for the automation. And the last one, and I think the one that it used to be a problem, but now I don't see it anymore, human workforce resistance. I think there's a lot of idea that, RPA or bots or automation can take away jobs, right? The idea that automation can displace people. So the communication of how RPA can help people is something that's very important too. So the premise is that no matter what, because you saw just now the presentation of AI, no matter what, technology will displace, or rather technology will be able to do things that it used to not be able to be done. Like for example, if you look at lawyers, right? When you look at processing contracts and work around creation of contracts and evaluating contracts, it used to be a very human thing to do. But now AI, the natural language processing, is good enough to be able to do certain things that now lawyers don't have to do, attorneys don't have to do. So people who are working on that part don't need to do that anymore. They have to move to another part inside the legal profession, right? Same with accounting as well. Certain part can be done by AI now. So there's a certain inevitability that AI will be able to do certain things, and you just have to move to different parts of the jobs, right? And so for the worker to be able to be on top of this trend, one of the best way to do it is to adopt RPA. So what you can do is that if a person adopt RPA, you use an RPA bot, and if you have access to the AI modules, for example, you can move yourself away from the things that are repetitive, away from the things that can be displacing you in the long future. And then you concentrate on things that are only the human beings are good at doing. There's a lot of things like this, like collaboration, for example, right? Like I told you just that I shared just now. I think things that like that, which is super easy for us to do, but immensely hard for robots to do, are the ones that we should move ourselves to. And RPA allows you to do that. It allows you to implement things that push you away from tasks that machines are better at doing. Okay, so that's the way that I think RPA should be communicated, because that's the reality. It's an empowering thing. It enables you to move towards more value-adding work. Okay. And finally, input standardization requirement. I think it's something that we discussed just now. Okay, so I come to the end of the talk. I think I initially wanted to put a 10 minutes break in the 1 hour mark just now, but I decided not to. So we have ended at 1:30 right now. So if you have any questions at all, I'll be answering them now. So you can just key it in the Q&A box. So if you look at your Zoom panel at the bottom, you should see Q&A. You can click on that, and then you can write any questions that you may have, and then I'll try to answer them. Okay, so let me answer some of the questions right now. Okay, the question is, I am autistic, handicapped, and like repetitive work. Will RPA take away my job? What should I do? So yeah, so for this, right? The idea is that you might be doing repetitive work, and will RPA be something that will be problematic? What should you do? One good move that you can do is, let's say if there's an avenue for you to adopt RPA. So there are free RPA software right now under Microsoft. that is free as long as you have Windows and maybe Office 365, I'm not sure. So this software is called Microsoft Power Automate. Okay, Microsoft Power Automate. And this software is something that you probably get access to already, just as is. Without any buying of licenses, you probably have access to that. So one good way for you to do this is that you should learn Power Automate in order to perform those repetitive tasks. And the action of creating that bot, right? The action of creating that bot to automate the task is something that a robot can do. A robot can create a robot. So a robot cannot problem solve. They cannot create a bot to solve a problem. So that is a distinctly human being thing to do. So you can still perform repetitive tasks, but in the context of creating a bot to do that repetitive task. This will give you a lot of value in the future because you'll be one of those people who can create automation to do things. And another thing that you can do is also to be moving towards collaborative kind of roles. So if there's any part of the job role that you're currently doing that requires collaboration, ideation, and improving things, you should move towards those two. And so again, while automation technologies are getting stronger and stronger today, it doesn't mean it will displace people, suddenly and right now. So there are ample time for us to pick up these skills in order to empower ourselves in automation. So that there is certainly time. Okay, the next question that is by Regine. Wouldn't the screening of AI of resumes already eliminate X numbers, even though RPA deems it as suitable? How does one solve this? Wouldn't the screening of AI resume already eliminate X numbers? So the question is, if you screen AI, already eliminate X numbers, even though RPA deems it as suitable, how does one solve this? So if you are referring to screening as in using AI to screen the resume, right? There are tools that does this. It's the same tool that the RPA is doing. They're using that same tool to screen the resumes. And the idea is that I want to answer it in two ways. One way is that if you're a job applicant, make sure you know that AI is evaluating your resume. This is true. So you must make sure that your resume is I can't remember the term, but it is AI friendly. It knows that how to list the information in a way that they can read easily. Okay, that's one. So the applicant must be more savvy in terms of how to create a resume. That's one. The other one is that the AI is the same between that is being used to evaluate the resume is the same, except that the RPA one, I think, is trained by hand instead of buying off the shelf. And so they can train it further. Okay, using user input. So that means the user can say what, and then they can train it further. Okay, I'm not sure whether I answered your question. You can ask more if I didn't. And I apologize if I didn't answer very well. So why would the non-integration into the system a bonus? Why would the non-integration into the system a bonus, Pro? I think you are referring to one part of my presentation. Let me see here. Oh yeah. Okay. So if we are referring to why is RPA not being integrated into a system being a good thing rather than a bad thing, right? It's mainly because integration into a system is very expensive, and after you integrate something into a system, it can be very expensive to maintain. So for example, if you change something, you have to change whatever that you integrate it to. And so it can be a difficult and expensive thing to do. So one advantage of RPA is that it resides at the user end, and so you can change it a little bit easier. But it does involve another set of problem. The set of problem that RPA introduces is that it might not be very holistic. It's like piecemeal, right? It's a bit here, a bit there, a bit here, a bit there. So at some point you must have automation in the system level also. Yeah, absolutely. But RPA is good for purposes where you need to be agile. You need to be quick enough to react to certain processes that are repetitive. So that's the system level automation is useful. So is RPA. So they have their different strengths. You certainly do not want to RPA everything and only use RPA. You certainly want to use some part at the system automation as well. So what's the criteria that makes the robot marks it as unsure and invites human? Okay, this is a good question. So the way they mark it is, and this natural language processing robot, typically what they do is, they have two things that they can do. One is you train it based on your current data set, and nobody does that. So someone else already trained them. So what they do is based on resumes and job roles that people deem a good fit to each other, they use this data set. If the way you write your resume is deemed suitable for that job role based on the way that the data has been trained, then it's a good fit. That means if you write your resume in a very minimalistic manner, other people write it in a very heavy and a lot of things manner, right? And then the training data using the heavy ones, then your minimalistic resume will not be a good fit. But conversely, if they train using minimalistic kind of data and yours is very heavy, then it also might not be a good fit. So it depends on the data set that they use. And you must also, there are guides online on how to make your resume AI friendly. What if data is in the government, can data be able to be retrieved? Yeah, I'm not sure about that. This question is something that I'm not so sure, whether data from the government is something that can be retrieved. Maybe in data protection, you might have to Google on data protection on whether data could be something that you can pull back from a government database. Can you share the type of hardware used to build artificial neural networks? Are they still using Intel Ryzen 3? Well, this is a good question. So the question is like, okay, you talk about training AI, right? Let's say you want to train AI and then use it for RPA. What kind of hardware do you need? It uses graphic card. So in terms of like consumer level hardware, they use very fast game. You know, like graphic cards are being used to render games, right? You know how the kids play games and they use very fast graphic cards. So that's the same thing that they use for training artificial neural network, because it requires a lot of computation. But in the server level, that means in the big games, the big leagues, right? Then they have rooms and rooms of servers, and they could be using Xeon processors or Ryzen processors, or NVIDIA's graphic cards specifically for training machine learning models. And all of these are very, very expensive, but you don't need the fastest card to learn AI. You can use a very slow machine and you can still learn AI. It's only when you want to train the very good models that you might need more resources. Okay, next question. Power Automate software can automate SAP. Okay, so the question is, so it's a Microsoft Power Automate, you told me is free, right? Can it work with SAP? It requires a connector. I'm not sure whether the connector can be is free or not. It might require a premium payment. But if I'm not wrong, okay, Power Automate is the not RPA. Okay, Power Automate is more like if you guys are familiar with the software called Zapier. It's like Zapier, it works on the back end. The Power Automate desktop, okay, look for desktop inside. That's the RPA bit. So it takes over your computer and do things for you. So Power Automate desktop can work with SAP for sure, because it just take over your keyboard and mouse and look into SAP and can click and do things on SAP. So definitely can. But Power Automate, the one that works, not residing on your computer, the one that automatically run things, that one might need a connector to work with SAP. That one might have to pay. So check it out. You can Google it and you can find. How much does it cost to install an RPA and AI? So for Uipath, right, which is the leader, there is a license cost, and it's best for you to approach them. If you just want to use RPA for your own use in the short term and you have access to Office 365, try Power Automate Desktop. So that one is free for you to use. Okay. So this is for you to get some exposure. But in the enterprise setting, sometimes you want to pay more in order to make things easier to deploy in a company, and that's why Uipath is pretty good at. Okay, so to clarify my question, the AI seem to have eliminated some resumes, but some of these are suitable because of needing human intervention. So it seemed, yeah, that is right. Yeah, okay, so this is a more profound question. The question is like, so it's AI seem to have eliminated so many resumes, but a lot of this resume might be suitable if a human being reads it, right? So it seemed to me that it's good for us to have human decision making in the resumes. Yeah, it is something that it is because of the amount of resumes that HR departments receive. It requires a lot of hours to read, and in a pragmatic manner, they have so many roles, right? They are just unable to devote the amount of time in order to do so. But you are absolutely right. So the idea is that AI at first can be a bit more like very rough, right? It doesn't get insights that you want, right? For example, and then in the future, if you want the AI to be able to pick up what the human being can, it will happen, but they need bigger data sets. So the data set must cover those cases where it doesn't look like a good match, but it's actually a good match. You got it? If the data set can have that, the machine can do just as good as the human being. But of course, we are still in the infancy of AI. We're still at the early stage of AI. I mean, we are still in the early part of information age, right? It's just a couple of decades, right? It's very new. So in the future, we'll have very stronger model. In the meantime, when you're doing job application, just know that you have to write in a way that is being chosen by the AI. At least it goes through. And not all companies use the technology, okay? Just want to tell you. Okay. So currently need to go into the system to check one by one the requirement info before copy and paste info into the email reply. Yeah, so these are some of the things that you can automate using RPA. Okay, you have to go to the system to check one by one the requirement info before copy and paste into the info reply. If there are any place and train programs for RPA offered by NTUC, I don't have IT expertise. Now we have an RPA course that's funded by the IBF. I believe we're still funded by the IBF. What will happen is our sales team will, our cost consultant, they will engage you via email on some of these opportunities that you have. You can use the SkillsFuture credit in order to pay for these courses. And we have an RPA one. There's a 5 days one also funded by the SkillsFuture that you can use the SkillsFuture credit for. So there's a long one that is 5 days long, and then there's a shorter one that's I think two days and 1 day e-learning. Yeah, so you can learn Uipath through these courses. Uipath is not like rocket science. You can really learn it, but you need to practice it. The idea is that you will get it kind of okay, and then after that you'll get stuck here and there, right? The only way for you to get really good at this is to unstuck yourself and keep learning, and then you can get really good at Uipath. All right. Would you be able to provide some resource links? We'll send you an email on the RPA opportunities courses that we have. All right. Other than that, if you want to learn online, you can. I mean, there are videos online also for you to learn RPA. Okay. So I don't have it right now. I don't have links for me to copy and paste. But you'll receive an email on the courses that we have. All right. The course links as well. We'll send it by email. Okay. All right. I think that's all that I have for today. I'll hand it back over to my friends from SkillsFuture.
Thank you, Isha. We hope that you have taken away some pointers and insights from this webinar. If you need guidance on your tech upskilling journey, you can sign up for the free one-to-one skills and training advisory session with SSG Skills Ambassadors. They'll have a conversation with you to understand your needs and objectives. It could be a new skill you are looking for to enhance your employment prospects or for your career transition plans, and share with you the relevant information. This includes course search and recommendations, type of assistance schemes and fundings, SkillsFuture credit, and other resources on my SkillsFuture portal. There are 3 ways to find or contact a Skills Ambassador. Visit us at any of the locations indicated on the map. Please note the operation dates and time. They will provide you with suitable course recommendations based on your career goals. Simply scan the QR code or click the link in chat to register, and they'll reach out to you within 3 to 4 working days. We have come to the end of our session. We would appreciate if you could take a minute to fill in the feedback form by scanning the QR code. Once again, thank you for taking time to join us in our webinar. Goodbye.